I'm going to be doing the graph of y is equal to 2 cotangent of the quantity x over 2 minus pi over 8. And I have drawn the graph of y is equal to cotangent x, just your basic graph. And remember that our cotangent function is equal to cosine of x over sine of x. And sine of x cannot be equal to 0. So when we have sine of x equal to 0, we end up developing asymptotes at those places. So we have an asymptote at x equal to 0 because sine of 0 is 0. And we have an asymptote at x equal to pi because sine of pi is also equal to 0. And therefore, my function is undefined and I have these asymptotes. Halfway between the asymptotes, I'm going to be crossing my 0 line, which is right here. And remember, if we have a vertical shift, it would be where it crosses the vertical shift. And then my quarter points, I'm going to have a point that's equal to my amplitude. So my amplitude here is 1, so at the quarter points I'm going to be either a positive 1 or negative 1. So we're going to use all that information over here to graph our function. So the first thing I notice is that my amplitude of this function is equal to the absolute value of 2. It's the coefficient of my function, which is 2. The next thing I'm going to see is that I don't have anything that I'm adding or subtracting out here, so that means that I have no vertical shift. Then I'm going to figure out my period, and remember that when we're dealing with cotangent and tangent, our period is always going to be pi. So instead of 2 pi over omega, we're going to have pi over omega. Omega is the coefficient of our x, and remember that there's a 1 in front of this x here, so my coefficient becomes 1/2. So omega is equal to 1/2. So then my period becomes pi divided by 1/2, which is equal to 2 pi. So my period is going to be 2 pi. Then the next thing I need to figure out is my phase shift, and I'm going to take the expression that's inside of the parentheses and I'm going to put it between my normal period, which would be 0 to pi. So I'm going to take x over 2 minus pi over 8, and I'm going to set it between pi and 0. And notice that I'm just making it less or greater than 0 or less than pi. I don't have that equal to sign. It can't be equal to these values because we have asymptotes and the function would be undefined at those points. So I'm going to go ahead and add pi over 8 to all sides of my inequality, and I end up with pi over 8 is less than x over 2, which is less than pi plus pi over 8. So pi becomes 8 pi over 8 plus pi over 8, which gives me 9 pi over 8. Then I'm going to multiply everything by 2. So everything gets multiplied by 2. And when I do that, my final answer then becomes pi over 4 is less than x, which is less than 9 pi over 4. So then that means that my phase shift is pi over 4 in the positive direction. This is going to be my first asymptote. This is going to be my second asymptote. So this is the beginning of my period. This is going to be the end of my period. So I'm going to go ahead and graph. So I've set up my graph, and notice that I have broken it down into pi over 4 increments, and I've reduced. So this is pi over 4. This is actually 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and 9 pi over 4. Now I'm going to go ahead and put my asymptotes in, and my asymptotes are going to occur at the beginning and the end of my cycle. So I need to have an asymptote at pi over 4 and 9 pi over 4. So you'll see that I've put my asymptotes here in brown, and then I've also marked in my quarter points and my halfway points, so I have an idea of where my function is going to be. So here's my asymptotes. At my halfway point, I'm going to be crossing the x-axis. At my quarter point, which is at 3/4 pi over pi, I'm going to be at my asymptote, or at my amplitude, and my amplitude is 2. So remember that your general shape of your cotangent function is going this way, and that means that I'm going to be at a maximum amplitude at the quarter point. So that means I'm going to be at my maximum amplitude, which is 2. So I go ahead and graph that in right here. I'm going to be at 2. And then at my 3/4 point, I'm going to be at my minimum amplitude, which is going to be -2. And then remember that your graph is going to approach your asymptotes but never cross them. So they're going to be going up here and going down there. And then we have a nice curve in between It looks like that. The next graph I'm going to do is y is equal to cosecant of the quantity x over 3 minus pi over 2 minus 1. Now remember, when we go to graph our cosecant functions or our secant functions, we're going to want to graph the reciprocal function first. So the reciprocal function for cosecant is sine. So what I really want to graph is y is equal to sine of x over 3 minus pi over 2 minus 1. And when I graph this, I need my 5 key points. That would be my beginning point, my ending point, my middle point, and my 2 quarter points. So I'm going to go ahead and do that, and I'm going to find my 5 points. And then once I find the 5 points, then I'm going to be able to graph my cosecant function. So I'm going to be looking at this sine function right now. And my sine function, first of all, I'm going to look at the amplitude. The amplitude is my coefficient of my function, which in this case is 1. So amplitude of 1. I'm going to be looking for my vertical shift, which is minus 1, which means I'm going to be going down 1. 1, down. I'm going to be looking at my period, and we're talking about the sine function. For the normal period for the sine function is 2 pi over omega. In this case then, omega is equal to the coefficient of my x. Remember there's a 1 in front of that x, so my coefficient is 1/3. So then my period becomes 2 pi divided by 1/3, which equals 6 pi. Then I'm going to figure out my phase shift. To figure out the phase shift, I'm going to take what's inside of the parentheses here and put it between what my normal period would be, which is between 0 and 2 pi. I'm going to have x over 3 minus pi over 2. I'm going to add pi over 2 to all sides of the inequality. I end up with pi over 2 is less than or equal to x over 3, which is less than or equal to, and 2 pi becomes 4 pi over 2 plus pi over 2. That's going to equal 5 pi over 2. Then I'm going to multiply every term within the inequality by 3 over 1 to isolate my x. So then I end up with x is greater than or equal to 3 pi over 2, and it's less than or equal to 15 pi over 2. So then that tells me that my phase shift is 3 pi over 2, which means I'm going to be moving to the right, and that if I take my period and I take the end of the period, 15 pi over 2, and I subtract the beginning of my period, 3 pi over 2, I should end up with the same period that I had before above, which was 6 pi over 2. So that checks. So now I'm ready to go ahead and graph. So now I'm going to go ahead and graph, and remember that your sine function, which is the one function we're trying to graph, looks like a worm. It looks something like this, which means that the beginning of my function, the end of my function, and the middle of the function, I'm going to be at 0, which in this case, we're going to need to go ahead and put in our vertical shift. Remember, our vertical shift is down 1, so I need to put that in first. And when I go ahead and put that vertical shift in, then I'm going to need to figure out where I start. Well, I'm going to start at 3 pi over 2. So notice I've made each of these equal to pi over 2. So this is 1, 2, 3, 4, 5, and so on and so forth. So 3 pi over 2 is right here. And I'm going to start at 0 according to my little graph here. But my 0 has moved down 1 unit. So that means at 3 pi over 2, I'm going to be down here. And I'll go ahead and make that in red. So there we are at 3 pi over 2, we're starting. And then we're going to end at 15 pi over 2, and we end at a 0 also. And then halfway in between, so we have to figure out where halfway in between is, and I should probably go ahead and mark those in here. So I've gone ahead and marked the quarter points and the halfway point in here, just so you can see what they look like. Normally we wouldn't even put those in here, but what I've done is I've counted that from 3 pi over 2 to 15 pi over 2 is 12 units. So I have an equal number of units here that I can divide into fourths. That means if I have 12 units, that means that each quarter is going to be worth 3 units. So this is my first quarter, another 3 units my halfway point, another 3 in my 3/4 point. So halfway point, I'm going to be, again, looking at my sine graph, I'm going to be at 0 again. So here's my halfway point, and there I am at 0. Then at my quarter point, I'm going to be at my maximum of my amplitude, and my amplitude is equal to 1. So that means from the vertical shift, I'm going to go up 1 unit, which actually brings me on to the x-axis. And then at my 3/4 point, I'm going to be going down 1 unit, which gets me down to -2. So now I have my 5 key points, and those are the ones I'm going to use to go ahead and graph my cosecant function. Wherever my graph crosses the vertical shift line, that's where my function is going to be 0, and therefore I need to have asymptotes there, because I can't have my function being equal to 0 there. So wherever they cross the vertical asymptote, the vertical shift, which happens to also be the x-axis when we're talking about no vertical shift, that's where I should have asymptotes. And then my graph is going to be reciprocal functions. It's going to be inverted. So instead of going like this, let me go very lightly in green, kind of dash that in there. Instead of my sine function looking like this, my cosecant function is going to look like this, and it's going to approach my asymptotes. Instead of looking like this, it's going to look like this. And that's one cycle of the cosecant function.